customers, and as promised, I'm back and we'll start solving combination sums, which is the next question from the list. Okay, let's solve it. Let's see what it has to say and give it our best to solve it. Let's reset this. Reset. Okay, so looks like given an array of distinct integer candidates and a target integer target. Okay, distinct, everything is distinct. A target integer target. Return a list of all unique combinations of candidates where the chosen number sum to target. You may return the combination in any order. Okay, the same number may be chosen from the candidate an unlimited number of times. Two combinations are unique if the frequency of at least one of the chosen number is different. Okay. The test case are generated such that the number of unique combinations that sum up to the target is less than 150 combinations for the given input. Okay. So the target is less than equal to 40 and the candidate length is less than 30. Okay, cool. So if a candidate cannot be created, I guess we have to return an empty array. So how should we get the basic fundamental of subset, like what we saw subsets, and apply it here? Right, in this case what it is asking us is to create the target, right, 7. So how can we use the same fundamental and go ahead solving the rest of it? Looks like we used a knapsack approach, like take one and leave one. So in this case, and we have to in subsets we have to do that until we reach the end of the until our index becomes equal to the length of the array, right? That's what we have to do. But in this case we have given a target and we have to make sure that we reach till there, and if we reach till that point, then basically we can add whatever the sequence of numbers we have got, we can add those to our result list. Otherwise we can just skip it. Okay, so that's what we have to do. So the first thing that comes to my mind is like and we can choose a single number any number of times, because to reach the target. So yeah, that's what we'll do. And once we go beyond the target, then we can simply say that we cannot achieve this target, right? That's what we'll do. So yeah, that would be the plan of action going forward with this approach. So basically what we have to do is, should I draw the tree for this one, or is it okay if I just don't draw the tree? So let's do that. Let's draw the tree for this one as well. So let's rub this out. Is it rubbing it? No, it's not rubbing it out. So let's refresh this guy. Okay, as long as there is no one, that is fine. Okay, let me select entire this thing. Okay, so what is combination sum? 2 3 6 7 is given and we have to create 7. 2 3 6 7 is given to me and my target is 7. So what I was thinking is, we'll start with the same idea. We'll have an empty array which we'll take, and we'll go through all the indexes basically. Okay, we'll go through every index and try to see if we can get to the target, and we'll keep the target here, which is 7. So we are at index, what the hell, so we are at index 0 when we start from here, 0, right? We either take it or leave it. So when we take it, what we'll do is we'll subtract it from the target. So our target would look like, so we'll add this 2 to our list, and at this stage our target will look like 5. Then what we can do is we can take that same number n number of times, right, until we go out of bound. So in our case, if we go below 0, then that would be out of bound basically. So what we'll do is we'll keep taking 2. Why is this happening? Why? Okay, so I'll keep taking 2 and not to take this 2. So if I take 2 and 2 at this stage, my answer would be if I 3. So yeah, like we'll do that again. We'll keep taking 2, so 0 and leave 0. We'll take 2, 2, 2. So at this stage our answer will be 1, and next time if we take 2, 0 and leave 0, so 2, 2, 2, 2, and the answer would be -1, right? So at this stage we'll say this whole branch of tree was waste of time and we cannot go any further than this. So we'll stop here and then we'll backtrack, and when we had just 2, 2, 2, what we'll do is we'll just write it down here, and then from here we can basically go to the next one. So obviously our target was 1 here, but if we go to the next one, which is index 1, then the answer would simply be 2, 2, 2, and the next was 3. So it would be obviously going beyond, so -2, right? Yeah, it will be -2. Answer would be -2. It is obviously not what we are looking for, so we don't go any further than this and return back. So we have, what we have here is 2, 2, 2, and with 1, and then we start exploring the other options. But as you can see, the other options are greater than what we have with us. So there is no point this 2, 2, 2 will lead us anywhere. So we'll basically see won't I won't draw this, continue drawing this tree, but this will eventually start returning back, because everything is greater than what we have. So we'll look at this this guy. Okay, so I'll probably, yeah, 2, 2, 3. So 2, 2 we have, right? So here we get 2, 2 and 3. So from here, if we see, we can go to next index, which is 1, 1. We'll take the 1. So 2, 2. If we take the 3, then our answer becomes 0. Oh yes, so this is what we were looking for. So this is what we are looking for. So we'll add that to our result array and then keep exploring further. But as you can see, the next items are pretty big. 6 and 7 are pretty big, so we will say why to explore them. Let's leave it, and we'll explore some other things. So what was the answer again? Answer was 7. So if you see, no matter how many combinations we take for these 2, 3, 6, we cannot reach 7. only if we go to 7, then we can say that yeah, we can possibly take this guy and then add it to the answer list. So this is what is going on here. So combinations, right? We are doing combinations. So I believe um, it will be n raised to n, which is exponential and is possibly the worst time complexity. If I'm not wrong, this would be n into n, because we are obviously taking n number of choices for n number of times until we reach the target. Yep. So the height of the tree at any given point would be basically reaching the height, the target. Yeah, the the target would be the height of the tree. That's what I'll say. Okay. So let's implement this. So basically, as we implemented the last part where we had the result, and then we had a backtrack function. Okay, we had a backtrack function which takes in the index that we are currently on and the temporary array. Okay, and then basically after running the backtrack function, we have to return the result, hoping that we have gathered all the possible combinations from visiting all, like trying out all the possible combination to reach that target. So yeah, that is that. And then function backtrack, what we'll do is index and then temp, let's call it temp. And what was our condition? If index temp, and we also need our target, right? That's what our target would be. So let's also specify the target here. So basically the target would be the one we might be reducing, right? So if our target is equal to 0, that is a perfect scenario for us to add that temp variable to the list, to the result array, and sorry, temp, and then basically return, because we don't have anything else to do. And let's say if there are two cases, if our target is less than equal to 0, let's say, or our index is equal to candidates dot length. Yeah, at that point we'll say basically we didn't find anything and we have to now return, right? We can return, we can safely return from here because we reached the end of the, or greater than equal to, let's say it is greater than equal to candidates dot length. Then we can simply say that we don't want to go any further, and we would like to visit some other paths. We would like to try some other combination, we can say that. And yeah, so once we reach here, so our logic of doing such operation is we basically add temp dot push the candidate, whatever candidate the index is pointing at, we'll put that into our temp, and then basically call backtrack on that particular same index, because we can take, remember, we can take n the same number n number of times. So that's what we do here, taking that same number n number of times, and give that temp to the backtrack, and also decrement the target by candidates index, right? That's what we are going to do. Okay, so once we have done with that, the next part is not taking that particular candidate to subtract the target with. So in that case we will pop the item and not take it, and basically go and visit some other route and do index plus 1. Yeah, and that time when we consider not to take it, we basically have to visit some other candidates. So for doing that, we increment the index and then target minus candidates of index, or we don't do anything, right? We just send the the target as is. So yeah, eventually once we visit everything, then backtrack, target, what happened? Oh, index is not defined, 0, sorry, my bad. So once we run this, okay, we did not get our answer. Why is that? Why is that? Target minus candidates of index. Yeah, we are doing that. Oh, I guess it might be referring to, let's call it tar, and let's call it tar. Let's call this tar. Yeah, I guess it might be referring to our other guy. So temp dot push max call stack size exceeded. Why is that? Why is this happening? So index, we take that temp and then temp dot pop, we are sending in okay. So yeah, like where I might be going wrong, I'm not understanding. So if index or index is greater than equal to candidates dot length, then I have to return. I don't want to do anything else. And oh, okay, yeah, I have to make the star as well, right? So okay, now it's behaving properly. So okay, if tar is less than equal, oh, less than 0, right? Less than 0. Why did I write equal to? So yeah, sorry, I mistakenly wrote 0 less than equal to, which was not allowing it to insert the answer. But once we have taken care of the edge cases, this will work, and hopefully we can submit it. And yeah, so here is the answer. So we use the similar technique from subset and just tweaked it a little bit, and we were able to get the answer for the combination sums. And then combinations would be the same again. um, okay, let's Let's write a note for ourselves that we solved this by ourselves. We solved this question by ourselves. Don't doubt it. Ourselves. Okay. And also for this guy, let me write that. We solved this question by ourselves. Okay, so yeah, that is that. And once we are done with this one, we'll see the combinations. Okay, once we see the combinations, I want to go to the permutations and then try out permutations 2, because that's where I got stuck today. And hopefully we can build up using what we have learned so far and apply it to the upcoming questions. Confirm. Okay, let's drink some water. Sorry about that. Okay, so the question is like this: given two integers n and k, return all possible combinations of k numbers chosen from range 1 and n. You may return the answer in any order. Sorry. Given two integers n and k, return all possible combinations of k numbers chosen from range 1 to n. Okay, you may return the answer in any order. So there are four choices. There are four choices. 2 is equal to 6 total combination. So note the combinations are unordered. 1 2 and 2 1 are considered to be the same combination. Okay. So we have to strictly move towards the end, and we cannot. Okay, got it. So 1 2 1 3 1 4. And k is equal to 2, right? That's what we have to take care of. Okay, the question is interesting. I would definitely say that. Okay, so let me understand this question. So k is equal to 2. Let me just read it again. Given two number n and k is given to me. Okay, return all possible combinations of k numbers chosen from range 1 and n, 1 to n. You may return the answer in any order. So my n is 4, so my range is 1 to 4, and k is equal to 2. So from 1 to 4 I have to pick out 1 2 1 3, okay, then 1 4, then 2 3 2 4. Okay, got it. So it's similar to the, not the combination sum but the subset sum. Like it is similar to this, like where we are taking 1, then 1 2, then 1 3. But in this case what we have to do is make sure that we are respecting the k, like whatever the k is given. So my question is, okay, So k will be always less than equal to, so if you see the constraint here, the k will be always less than equal to n, less than equal to n, and it will be greater than 1, greater than equal to 1. So yeah, that is that. And our n will be between 1 to 2 inclusive. Okay, I understand the question. So, so whatever we have seen in subsets and combination, we were using knapsack, right? Take one, leave, take it or leave it, right? So can we use the same method here when we are building our result? So basically, we have to do the same thing. We have to have a result. We have to backtrack from 1 to n, keeping respecting the k, and yeah, once we reach the k, then we have to start like store the result and start returning back. So we have to our base is clear. Now we have to add on top of it for this particular question. Okay, so looks like we once our temporary variable reaches the value of k, when it is equal to k, at that point we have to push it. So that is our base case, that is done. Okay, so when should we stop, when should we return? That is the question, that is the important question that we have to address here. We have to stop when our index basically goes above so we'll be starting from, let's go back to the board, and we can solve this question over there. Let's say if I can still do I still have the access of the board? No, I don't. It doesn't look like that. So let's refresh it. It sucks like how Miro board is not responsive when we get back to it, but okay, it's a free tool, it has its pros and cons, and I'm totally fine with it. Not totally, but yeah, just fine with it. So n is given to be 4 and k was 2. So basically what I was thinking is we'll start from index 1. Okay, we'll start from index 1, and yeah, we'll build it from there. So our array is empty. We start from 1, we take 1 or leave 1, right? So that's what we are going to do. So if we take it, then our 1 will be here, and then what we'll do is we'll go further, we'll go further and keep incrementing the index. So we'll take 2 or leave 2. If we take 2, then 1 and 2 would be the 1. But wait a minute, and what we'll do here from here is we'll go to 3, but we cannot go to 3 as it is, the length is equal to 4, equal to 2. This guy will be one of our result. Okay, so we'll return from here, and we'll start exploring different tree, this tree, when we'll leave out 2. So we'll just have 1 here. So from here we can go to 3, right? That's where we can go. So either we take 3 or leave 3. So if we take 3, then it will be 1 and 3. So it looks like we have also reached here the k. So we'll add this to our answer and we'll return. So once we are at 3, so this branch was leaving the 3, right? So this will be just 1, and from here we can go to 4, take 4 or leave 4. So if we take 4, this will be 1 4, and if we leave 4, this will be 1. And here we have reached the k, so we take that, and here from here we can go to go to the next index, which is basically we going to 5, and we cannot reverse this because it is exceeding the number of n. So that's why we'll return from here. And so we will end up returning till this point, and then we'll start looking at the right side of the root. So we decided to leave 1, right? So this would be empty. Now we decide from 2 to take 2 or leave 2. So if we take 2, we will have 2, and then we'll keep exploring this branch. So for simplicity's sake, what I'll do is I'll just move out this branch a little bit to the left so that we have some space and we are not running out of the space. Yeah, so we have to, and then from here we can either go, we go to 3, and we can take 3 or leave 3. So 2 3 would be the one, and this is one of our answer. Then we go to 3, we decided not to take 3. Then from here we can go to 4, then 2 4. So this is also one of our answer, and from here we cannot go anywhere else. So this would be the end of this thing, and then we'll be returning back to this guy, which is 3. So the same story will happen here, and at the end we'll end up with our answer, which is, if we go back, we have 1 2 1 3 1 4, right? So it should be having the same. Yeah, so as we traverse the tree, it will have 1 2 1 3 1 4, then 2 3 2 4 and 3 4 at the end. So hopefully, okay, so why don't, if we are just one answer away, then why don't we just explore the tree? So we'll be just at 3, right? So what, from here at this point we can go to oh, sorry, my bad. That's what I was thinking. What did I do here? So yeah, at this point what we can do is we can go to 3, right? So we take 3 or leave 3. So yeah, once we take 3, we can, from this point we can go to 4. So we'll take 4 or leave 4. So 4 comes here, 3 4. So we've got our another set, another pair that satisfies, and then this guy goes 3, and then again 5, it reaches 5. We cannot go do anything further, and yeah, that is the end of this one. So as you can see, we've got all our answers, and yeah, so the time complexity of this would be 2 raised to n. Yeah, 2 raised to n. For every position we are taking branching out 2 times, right? 2 raised to n, that's why. And the space complexity of this would be n. N or okay, yeah, I suppose it should be n. Yeah, because we never will go beyond the size of n. So yeah, that should do it. So combinations, right? So let's code it out, and basically let's follow the same strategy that we have followed so far. We have a result that we have to return at the end, so we'll be returning that. We have to start backtracking from index 1, right? And our temporary variable would be an empty array, and our k would be this guy. Our, I guess we don't have to specify the k, we just have to send the empty array. Okay, yeah, because if you know closures, this would be having access to our lexical scope, which is this. So the backtrack lexical scope will be this. Yeah, so that will have access of k. So we have index and a temp. Okay, so our what was our base case? If our index at any point it goes greater than the n plus 1, so greater than or equal to n plus 1, then we have to simply return. We don't want to go ahead. And if let's say our temp dot length is equal to k, at that point we know that um, we can store it in our result. So result dot push, what we do is, okay, and also I forgot that pushing it to the array is also n task. So n into 2 raised to n would be the time complexity once we consider the pushing part of it. Like we are copying the array, right? That's why we have to do that. Hey, hey, thanks, man. Like, yeah, like I'm doing it every day because I'm actively interviewing and I'm liking what like I'm liking the streaming. So thanks, really appreciate it. Okay, so we where were we? We temp dot length equal to k, and then we can simply return it from here. And the next thing is this. Okay, I just my flow. Okay, let's get back to this. Yeah. So this is our base case. Basically, our base case is done. Now the basic simple part where we take it or leave it. Um, so I don't do contest as of now. So my basic strategy is to look at all these questions as if like as if like as simple as that, like as you go to gym and you work out, like you do a chest day, you do a back day, simply like that. I'm treating this as areas that I want to target in a day. So and yeah, that's what I do. Like I do couple of questions like easy and medium from this list every day. So yeah, that's what I do. We got two on Saturday. They are pretty good. Okay, yeah, I'll try to do a contest this Saturday. If I don't know if you watch UFC or not, but if the match is there, I and if there is a conflict between those two, I might skip it. I haven't solved 450 questions. I've just solved 191 out of this list, and it's not about the number. I so if you see this backtracking, I've solved these questions again, but I'm going over it again. So to just um, get a better understanding of what is going on, and hopefully I can solve other questions as well, um, using the same foundation of yeah. So yeah, like as I was saying, I'm sure we both watch UFC legally. Yeah, definitely. Being a UFC fan is surely tough, but yeah, I watch it legally. I pay for pay-per-view. Even if I don't have a job, I find I build up that credit, and then yeah, I pay for it from there. Yeah, sure. Dana is getting a lot of money after selling that pay-per-view of Iguanu versus, who was that? Tyson Fury. Yeah. I guess he might be furious after that, after looking at those numbers. But I heard that the pay-per-view numbers were not that great for Ngannou versus Tyson Fury match. I'm not sure, but I'm sure he might be looking forward to get him back onto the roster or get him back to the UFC because he's really a real deal, Ngannou. So yeah, hopefully. I don't know. Okay. Where were we? Yeah, yep. Third round, right? He dropped him in the third round. So, like, once he dropped him, like he was not playing that aggressively because I guess it was his first time. He might be having some jitters. He was looking slow, but as the round uh, went by, he looked pretty confident. And then when he dropped him in this third round, then in fourth round, you must have seen him. He was really flowing. He was in the state of flow. He was looking quicker. His jabs were like fluid. Yeah, like I thought that shifted the match a bit, but Tyson showed like his composure. He was not doing that great because I didn't see a single point where he was dominating Francis. Uh, Francis was having not having a bad day in there. Like he was just um, there, and he was trying to land some good shots, and that was brutal when when Tyson Fury elbowed him. Yeah, that wasn't nice. And the decision was pretty much not great because I guess it was Tyson Fury had a match in has a match in December. That's why they might have given him a win. Otherwise, otherwise a win should have gone in France's favor. But it is what it is. We can't do anything about that. So backtrack index. I guess we have to do index +1 and then send the temp and simply now not sorry pop not take the index and backtrack index +1 and temp, right? That's what you have to do. um, I don't know, the editorials for those are solid. Like, I don't know if you have checked out the JS section on LC. Um, what JS section are you talking about? Are you talking about the editorial or the solutions? Yeah, the editorial solutions are pretty solid, like are really solid. They are getting day by day. It is getting better, but yeah, I tried I try to read through those editorials, but sometimes it feels like a overkill. Like I'm so exhausted just by thinking about the question and coming up with the solution that by the end of it, okay, let me check that out. It's not just algo. Are you talking about this one? This guy? What are you talking about? I guess you might be talking about this itself. My internet connection is pretty bad, I know. Um, but yeah, it is what it is. That's one part of it. Talking about the problem listed. Oh, okay. Oh, oh, okay. They. Oh, that is cool. They have added a lot of. Oh, that's nice. I didn't see this. The last time I saw it was just. Oh, okay, okay, okay. Now I see what you're talking about. Okay, cool. So yeah, I'll definitely take a look into this. I haven't. I didn't know this. Thanks for bringing that up. So I'll definitely look into it. But I have been solving questions from BFE.dev, and they are also pretty good. Like the community over here is also nice. Like it's not the content like the interface is not as friendly as lead codes, because lead code has a mature UI, and they have been in this game for longer time. But yeah, like I have been solving this few questions from here, and they are absolutely like really good. And they have also sorted it based on company list, and I've also created few of the lists that I've done from this platform, um, which is pretty yeah. And recently I appeared for a Google interview, and they asked this question: implement deep equal. I was able to partially solve it, like not partially, like this was not the original question. The original question was something else, but as I was not able to solve that, they gave me this one. And I struggled in this one as well, but was able to solve this with some hints. Um, yeah. Um, the interviewer doesn't think that, but I hope like I'll find a job sooner or later. So that's why I just don't want to stop whatever I'm doing right now. I like streaming, like basically if I can help out anyone by my explanation, that would be nice. I don't do some polished videos, but I just like to do stream. That's what keep me focused. I don't. Yeah, that was pretty weird. That was pretty weird because um, no, I'm in New Jersey, USA. It was in US. Are you from US originally, or how or which part of the world are you talking from? I guess you are from US. Are you? Yeah, you are from US. So you spoke in dollar terms. So you are from US. Like yeah, hiring is picking back a lot. So what happened was I had oh, California, that's cool. So it might be like 6 p.m. at your place, 6 5 p.m. at your place. Because you said dollars, like Dana wants the money $80, right? That's what you said. So based on that, I thought that's yeah. Meta is also picking up, but I got a referral for Meta, but my resume didn't get selected. Didn't get select in from Meta for Meta. I don't know why. So I'm again looking for a referral. So the person I asked referral from, she went to her home, like she went back to India. So I guess she might be on trip. Yeah, you were exposed, man. So yeah, like she went to India. So no way for me to ask her again for a referral. But as I was saying, I had this Google interview and Amazon interview in the same week, and for Google, that I thought, as the recruiter told me, they will ask me all algorithmic questions. So I started grinding the lead code in that. So I took like about 3 weeks of time for. So I'm I don't know what level I might be targeting. Like I will be targeting like I have 5 years of experience on paper, but yeah, but I was from a consulting background, um, and when with respect to the UI, I might have just 3 years of experience, but nonetheless, I'm targeting either 5 years of experience or 2 to 3 years of experience. So anywhere between that, yeah, 2 to 5 years of experience, I'm targeting positions. Cutting it close. Yeah, so I was saying that yeah, I took the interview in 3 weeks, and as the recruiter told me that they will ask me algorithmic questions, so I was just preparing algorithmic questions, and I was also solving questions from BFE, dev, but but later on the interview day they asked me. Either one should pay way more than which. Yeah. So yeah, the also on the interview day, the interviewer asked me that suppose you have two JSON files, you have to find the difference from that from those two JSON files, and once you find the difference, you have to take that difference, put into the first JSON file, and create the second JSON file. So after listening that problem, I was like, what the fuck they are asking me, like, but I composed myself. I did not stop talking, and I was explaining him where am I getting stuck, uh, what what approaches I can use and all that stuff. So, but I was struggling a lot in that interview, and it didn't go my way. It is what it is, but it was a nice experience. Yeah, looks like now they are like the two interviews I gave for Amazon also. I think I lost. I solved the question that was asked for the interview part, but behavioral part I did not give him a good example. Basically, my friend also works at Amazon. He told me that uh, the example that I should have given for the behavioral should have shown a scale, like what scale I have created impact, rather I gave him an example of uh, what do you say, a simple example. I gave him a simple example that I guess that might have caused rejection for the Amazon one. But yeah, uh, I'm thinking of applying for that position for to Amazon again by changing my email ID. because they looks like they are hiring 25,000 positions are opening. If you are on blind, I'm not sure if you're on blind or. By the way, which company are you working on? Working with or so blind is really they don't have a dark mode. Looks like. Yeah, the so I did that, but I did mocked interview with ChatGPT and got the so, so that okay. So I saw a post on Blind where they mentioned that Amazon is going to hire like 25,000 roles or something. I'm not sure. Home uh, jobs and referrals. If we go in there, yeah, I'm yeah. I apply. I took a referral for Dropbox. Grammarly is also hiring a lot. I'm basically all I'm doing is going on to the LinkedIn, spamming random people. Yeah, no, blind is toxic. I know. I know. People like to flex about their company. So see, there I posted one comment here. So someone just replied. Let's see. We've got front end roles open at TikTok. DM for referral and if interested. Hey, the community is nice, man. They keep calling me Rajesh. Why? Are you an Indian or so if you are no condomrest, why they keep calling you Rajesh? That's weird. DM for referral if interested. Thank you for OpenAI Anthropic etc. Did you try AI companies? Um, so I guess I might have. I might have Anthropic. Anthropic I haven't tried. Let's see. LinkedIn.com. I haven't tried Anthropic. Yeah, TikTok being big. I got referral for TikTok. Thank you for. So let me just reply to him. Thank you for. Um, what do you see? Thank you for. Um, just read blind more and you'll see. Really? Okay. Thank you for offering the referral. Um, um, employees. Um, someone at TikTok already referred me. You guys are super helpful. Thanks a lot. Thanks a lot. Post. Okay. So yeah. DM me. Okay, Meta. Oh. So yeah, this guy did offer to um help me out. So I'll DM him. But Anthropic, right? You said Anthropic. Anthropic. So I looks like I've got software development engineer 3 front end role open at Valoram. Valoram. Okay. I'm not sure what is this. Okay. My company has an SD3 front-end role available, and I believe your profile highlighted a lot of what we are looking for in terms of background experience. As a software engineer, you will be part of a team of a talented developer, business analyst, QA, whatever. Okay, you will work on developing .NET shoots based solutions on Azure and work with strong team in fast-paced environment. I guess she did not see my profile clearly. I'm not a .NET developer. Like why .NET? Okay, let's check out what the solution is. Anthropic, right? Okay, cool. Thanks, man. DM that guy right now. So Anthropic. Okay, this is software engineer. This is software engineer position. Okay, let me yeah, I'll do that. I'll DM that guy. Take the referral. Um, okay. How do you do that? Okay. So I'm not using blind a lot. So yeah, kind of struggling with uh, send private message. We are sorry, this feature is currently available on what the fuck. Okay. Okay, I don't have my phone with me right now, so otherwise I would have sent it right away. Yeah, recruiters are like that. Cool. Are you working? I guess I did I ask you that already or did you answer that already? I'm not sure. Okay, let me uh, bring that chat up here. Save. Okay. Yeah, yeah. So yeah, that's what my phone is upstairs. I'll go upstairs and I'll probably message him right now. So you are working. I guess that's why you said yeah. So which company, if you don't mind sharing that, which company are you working for? Overlay Pog. Yeah, the lag is insane. So my internet connection is not that great. So yeah, the lag is really bad. Lag is super bad. I know. I don't know how to fix that. Mm, yeah, it is. It is. It is thick. Um, I don't know how should I get rid of that because I'm use like my internet service provider gives me 1 Gbps, but I only end up getting like 200 or 300 Mbps of speed. So that's really bad, but I don't know. And my router is upstairs. Um, I think I might need a what do you call it, extender, or the router which makes the signal stronger. I guess I might need that. So where were we? So the answer is kind of getting, it's wrong. So um, should we just use this instead of that? Okay. Okay, now it is accepted. Cool. Submit this. Yep, there it worked. Yeah, is it? It is cable. Yeah, it is cable. Um, with terrible upload. Yeah. So if I'll show you my speed. Internet speed. If you see, I'll run this. See, I am always getting this kind of speed, and it's even worse now. Like when I'm streaming it or I don't know what, and my upload speed is like 12 mbps, and it should be more. I don't know. I should be. Yeah. So it's pretty bad, right? As you can see. Sometimes they do like 1 gig download and like 15 upload. Yeah, it's pretty bad. So I don't know. Like I'll do some research on how I can. Yeah, I'll do some research and see how I can boost that speed up. I guess my router is CAX. This is my router. CAX 30. I guess, yeah. This is what my router is. This guy. Maybe your next place, get a place symmetrical fiber. You won't be able to go back once you upload YouTube's at 1 GB. Oh wow. Yeah, so this is my router, man. So I'm not sure if, oops, I'll just paste it here. Yeah. Cool. So what I'll do is, so we I guess the combinations, like coming back to this combinations, sorry about diverging. So yeah, like why didn't I star mark it? So this is pretty important. So we solved today these three, and in morning I solved this one. um okay. So it's been 1 hour, I guess, since I started the stream. Hey Chris, I guess I'll end the stream now, and it was nice talking to you. Mm, and in next stream, probably I'll do few more questions on this backtracking, and then tomorrow is my graph day, so I'll be doing some questions from graph, and as you suggested, I'll also start working on the question like the lead code JavaScript questions. I really need to do those sort of questions.